In this example, a square sheet of tin measures 12 centimetres by 12 centimetres. If we have a look at the diagram there, you can see that 4 equal squares of edge x centimetres are cut out of the corners and the sides are turned up to form an open rectangular box. Open rectangular box. So you can see here that these are all squares that have been cut out of the rectangular piece there to form that box. Well, straight away, before I even start answering the questions, I can see the length of that rectangular box is equal to 12 minus 2x. 12 minus 2x. The width of that rectangular box is also 12 minus 2x, because remember, I'm taking away x from the 12. And then the last little bit there is because we've folded it up, then the height must be equal to x centimetres. Now in part A of this question, we're asked to find the volume of the box. Well, it's a rectangular prism, so we should know that volume is equal to length times width times height. And it really doesn't matter what order we put things in because it's multiplication. So I put the height first and say x times 12 minus 2x times 12 minus 2x. Now that's what the volume is equal to in terms of x. Could I expand that out? Yes, I could. Is that a feasible answer the way it is in factor form? Yes, it is. So depending on what the question asks you to do would depend on how much work you would do to finish off that part of the question. The next bit says the values of x. So find the values of x for which the volume is 100 centimetres cubed. All right, use the calculator here, and into your calculator you would put, okay, so you're using the solve function, and this is your function. It is x outside of 12 minus 2x times 12 minus 2x, and we want that to equal 100, comma, x. And when you put that into your calculator, you get x equal to 1, x equal to 3.2, and x equal to 7.79. Now, mathematically, they are all correct answers, but we are not going to accept all of them for this particular problem. If I substitute x back into any of these, it has to make sense and not be negative, because I can't have a negative length, a negative width, or a negative height. So let's take this 12 minus 2x. If I put 1 in there, 12 minus 2 is 10. That's feasible. What about if x is equal to 3.2? 12 take away 6.4. That's still a positive length. Okay, what about the last one? 7.79. So 12 take away 2 times 7.79. Well, already I can see that that's a value. 2 times this is bigger than 15, and I'm going to end up with a negative length. So in actual fact, this is not going to be one of my solutions. My two x values there are 1 and 3.2. Now, the next part of this question, use a CAS calculator to draw the graph of v against x for suitable values of x. This is really important. What are the suitable values of x? Well, the actual graph is drawn down here, but why have I only got that part of the graph? Now we know that volume is equal to x outside of 12 minus 2x outside of 12 minus 2x. Volume is 0 down here. So I'm going to let each of them equal to 0. So x is equal to 0 and 12 minus 2x is equal to 0. Well, when you transpose that, you get 2x equals 12, and then x is equal to 6. So our graph goes between 0 and 6. Are we going to include those two values? No, because we don't want the volume of the box to be 0. So therefore they would be open circles there. So at 0 and 6 on our graph, the bit that we want, we have got open circles at between those 2 points. Okay, the maximum volume of the box. So the maximum volume of the box is obviously the maximum turning point, and we've looked at that before when we were looking at quadratics. You use your calculator, analyze graph, and you can find the maximum there. So the maximum volume is 128 centimeters cubed. And where does it happen? Which value of x? At x equal to 2. So these last two parts were done on the calculator. So the really important thing to remember from a question like this is, although mathematically we might get some answers, they're not always necessarily going to be answers that we accept for the situation at hand. In this particular case, length, width and height all had to be positive values, bigger than 0. And so did the volume. You can never have a negative volume or a 0 volume. You want it to be bigger than 0. So they were the things that guided us in terms of sketching our graph and getting our answers out.